Today we're going to talk about Azure Arc enabled Kubernetes cluster, and today's agenda will be about, let's write the agenda here. So I'll introduce Azure Arc enabled Kubernetes cluster, and we're going to install new AKS-HCI. So at least I need a Kubernetes cluster to enable Azure Arc enabled Kubernetes cluster. And then we're going to install Azure policy for containers. And we're going to introduce the connect from anywhere feature. And we'll talk about Azure Defender for containers. And we're going to discuss about container insights, and in the container insight we will discuss monitoring, and we will discuss logging and monitoring and logging optimizations, and after that we will install data Arc enabled data services. And let's look at one of them. What can we add? GitOps integration. I will just touch GitOps integration. It is very easy process, but I'm not going to, too much pay attention to GitOps integration. Yeah, it's okay. So let's go to the Arc. So find another topic to add. So we can install PostgreSQL server, data services, PostgreSQL, and SQL Managed Instance. Let's write this down here, GitOps integration. So agenda is, I think, okay. So let's start. So what is Azure Arc enabled Kubernetes cluster? So basically, what we are trying to achieve with the Arc enabled Kubernetes cluster is we are trying to get the management plane, separate the management plane of the Kubernetes environment and delegate to the Azure cloud. And after that, we're trying to bring our cloud native services into the any Kubernetes distribution. So basically, let's say that, let me search for a shape in here. Kubernetes, and I don't like this icon. Okay, let's say that we have Kubernetes or Elastic Container Service for Kubernetes, or Google Kubernetes Engine, or let's call it something like Rancher. Let's put something to here. Again, let's search for Kubernetes. It continues like this one, okay? So any Kubernetes distribution rather than AKS Azure Kubernetes Services, we're trying to bring the Azure capabilities, Azure Kubernetes Service capabilities into these environments. So if you install Arc, if they have this Arc, yeah, Azure Arc capability on top of these Kubernetes distributions, and let's multiply by this one, and well, let's multiply this one at that Azure Arc. So we add the Arc capability into, let's say, that Kubernetes on-premise Kubernetes environment, or AKS, or not AKS, EKS, GKE, whatever you have, whatever your Kubernetes distribution is. With the Arc enabled Kubernetes environment, basically, first of all, we have the policy integration in the Azure cloud. This is an old icon, so let's put a new one. So Azure policy is for compliance and regulation processes. So basically, we are bringing the in-cluster policies to the Kubernetes clusters. Let's say that I have a privileged container, and who is going to audit it? Who is going to deny if there's a privileged container? Or let's say that the container is running as a root user, so we should audit it. With the policies, basically we integrated with Gatekeeper, and let's put them here, and let's put, it is integrated with Gatekeeper. We're deploying Gatekeeper and evaluating the Gatekeeper results and showing on the Azure portal. And after that, we bringing these services. And after that, we have the Defender for containers. So if you enable Arc, again, you will have the Azure Defender capabilities. So let's say that to here, and so here. I think it's okay. To here, and from to here. So you have the compliance component and the container runtime security product in your Kubernetes clusters. So other than that, let's say that, what about the logging? What about the monitoring stuff? What about the visualization of the logins and the monitoring stuffs? We have a container insights for that, and let's call Azure Monitor. Not that one. If I can find it, a good icon. Again, it's an old icon. So let's put it here. Again, with the Arc, we have this capability monitoring your container environments and logging your environments. So let's say that, I mean, these are the management capabilities, but also we can bring, let's say that, SQL Managed Instance. With the Arc, you can install SQL Managed Instance or PostgreSQL Server on top of your Kubernetes environment. Or API management, you can install API management services, or you can install web app. Let's search for again. Let's call it web app, not this one. Web application. It's a WAF, but let's call it web application. And we can install functions. Function apps. We can install logic apps. We can install IoT Edge. We can install machine learning. Yeah, that one. So with the Arc, we can install these products on any Kubernetes cluster, and we can install our managed offerings, PostgreSQL Server with single instance or Citus extension, or SQL Managed Instance with general available or with business critical. And we have the integration with the Azure policy for auditing your Kubernetes containers compliance and auditing. And if you want, you can deny it. We can install Defender for containers for runtime analysis. You can install Azure Monitor Container Insights, and then you can ship the logs and Prometheus exporters metrics to the Azure cloud. And basically, of course, Azure Monitor is integrated with Log Analytics Workspace. You can query your metrics and the logs from Log Analytics and build your custom dashboards here. So basically, Arc bringing the management capability to the Azure cloud for on-premise or GKE or Rancher or Amazon EKS services. And we're bringing PostgreSQL, SQL Managed Instance, machine learning, API management, web application, function apps, logic apps, and IoT Yash to any Kubernetes distribution. So let's start from scratch. So basically, what I need is just install any Kubernetes environment. I need to have one Kubernetes environment to demonstrate these things. So let's start from scratch. I don't think we have a history for PowerShell. I don't know. Okay, remove. It was the first comment. I need to find a comment. So first of all, I'm in my environment. I have AKS-HCI. As you can see from here, it's the AKS-HCI host. I'm going to create a new AKS cluster, AKS-HCI cluster on top of my on-premise environment. AKS new AKS-HCI cluster. So let's search for this comment, and then let's copy one of the comments in here. Okay, so it's I think too much for me. So the comments that I'm going to use here, I will put every comment to here, and they are generated to YouTube video. New AKS my cluster. Let's call it PMR CLS. Node pool name is Linux pool. Node count. Let's make it 2 k.s. So very good question. I need to standard. This one is okay. Oops. And OS type is Linux. Let's make it 3 actually. Okay, and then let's execute this command to spin up a new Kubernetes environment on my local environment. So it can be AKS-HCI as well in here. So let's put it to our diagram. AKS. Okay, there's no such a thing. Azure Kubernetes. Okay, Kubernetes image, no shape library. Okay, Azure is okay. Let's search for something else. Let's search for again. Kubernetes. Kubernetes services, and let's make it to here. Let's put it this one to here, AKS-HCI. Let's call it AKS-HCI. Okay, cool. So as you can see, my control plane spin up. My load balancer is spin up. A couple of minutes later, my control plane for PMR CLS cluster will be spin up, and after that, the worker nodes will be spin up, and after that, we can install Arc-enabled Kubernetes on top of AKS-HCI. And this process is all same, but it's not the best practice to use this same comments. I'm going to use this comment, connect Azure extensions. So you can use your Arc-enabled Kubernetes cluster to connect your Kubernetes cluster to our Azure portal with this comment, but normally with the AKS-HCI to enable the Arc connection, AKS-HCI enable Arc, we should use this comment. Enable, it should be something like enable AKS-HCI Arc connection. So for AKS-HCI, you should use enable AKS Arc connection, but for other Kubernetes distributions, you should use where are you? This comment, AZ connected K8s connect comment. So there's very simple difference between AKS-HCI for enabling the Arc and then the other Kubernetes distributions. So okay, let's wait a couple of minutes, as I said. And while I'm here, if there's a question, comments. Okay, there's no comment. Cool. Let's wait couple of minutes to spin up the AKS cluster. Right now, if you ask me where I am, install new AKS. We are in here, installing new AKS-HCI cluster. Let's call it cluster. And let's wait. Load balancer is okay, control plane is okay, and worker nodes will be spinned up in a couple of minutes. And let's wait. So to use AZ-CLI to enable Arc-enabled Kubernetes cluster, we should first of all execute this command. So basically, it's a client-side extension for Azure Command. I have already installed it. Let's put it to here, and then Windows PowerShell. Let's execute one by one, and it's okay. For OpenShift, to enable Arc on OpenShift, we should execute this command. I don't have the OpenShift environment, so I don't need to execute this command. And these comments are also important for the first time you're installing Arc on top of Kubernetes, any Kubernetes distribution, or if you don't install AKS on your Azure Cloud subscription, then we should enable these services, AZ provider register comments, and we can query the registration status with this comment. So let's execute this comments to see that actually if it is registered or not. Is on my subscription, as you can see, it is registered. And let's execute this command, Kubernetes configuration. So not this one. Let me copy Kubernetes configuration registration. Okay. But before that, you should execute this command. I don't need to do that actually. I'm trying to show you the output of the status because I have already done it. It's very easy to enable these services. So the three services should be, registration status should be registered. This one and this one. Let me just make it a little bit bigger. Yes. So after that, if it's registered, still waiting for the worker nodes. The worker nodes will be spun up within 2 or 3 minutes. And if you are in an enterprise environment or if you are using a proxy, then this endpoint should be enabled as well. Management.azure, depending on your region, these URLs should be enabled for proxy communication or firewall. So if you don't enable, then you cannot install. I mean, you can install the Arc, but you will not see that the Arc-enabled Kubernetes as connected in the Azure portal. So we need to have a resource group. So let's create a resource group on the Azure portal. So let's go to here and then let's play with comments. Name. Let's set a name. Arc. Azure Arc demo. And West Europe for the region. So basically, I'm creating a resource group in my subscription. And here we go. Okay. Azure group list all table to list my resource groups. So Arc clusters, Azure Arc demo is just created. Okay, I'm good to go. Still waiting my work nodes. And machines are not running phase. So, okay, let's wait a couple of minutes. And after that, I can execute this command. So basically, this command will enable the Arc, the projection of my Kubernetes environment in Azure Cloud. So you are saying that, I mean, normally if you have Azure Kubernetes Services or SQL Managed Instance or PostgreSQL Server, if you create it from the Azure Cloud, you have the icons like in here. So let me show you. Right? Let's say that if you install Azure Kubernetes Services, it seems like this one. If you install SQL Managed Instance, it will be in the Azure Cloud portal, and you can click and play around it. So basically, your Kubernetes environment will seem like an Azure resource. So to make it this projection, we need to execute this command for Kubernetes cluster. So let's fix this command for our environment. Connect name. So these names shouldn't be important, but PMR CLS Arc cluster resource group is Azure Arc demo. So if I execute this command against my Kubernetes cluster, it will appear in Azure portal Azure Kubernetes cluster as a native Azure Kubernetes environment in Azure portal. Still waiting my environment for, I'm just spinning up the Kubernetes environment, my Kubernetes environment to enable Arc. Let's wait. Okay, there's no question. I'm good to go. Good. Wow, I created 3 nodes. Okay. So what is standard D4 SV3? So basically get VM, I think this comment. No. So let's execute this comment, get comment dash module to understand that the VM specs, get comment dash module AKS-HCI, and list it. Waiting, still waiting. Okay, cool. So I should find the VM comments, VM SCR-I, VM. So get AKS-HCI VM size. If I execute this comment, as you can see, I can set on the AKS-HCI only these VMs as specs. So D4S, memory gigabyte, okay. So 4 CPU, 16 gigabytes of memory. I hope I have that amount of resources. I don't know what's going to happen right now. Okay, control plane. Okay, wait. Let's wait. Okay, no question. Good. So again, I should wait. I know. I should teach myself to wait. For the new joiners, I'm trying to create a Kubernetes cluster from scratch on AKS-HCI. Load balancer, control plane. Seems okay. Okay, cool. The control plane is created for my target cluster. So we're supporting on the AKS-HCI node pool auto scaling. So right, if for the initial phase, it's just disabling the auto scaler of the cluster. And after that, the new AKS-HCI cluster will spin up the worker nodes. I'm waiting for node pool to be created. As you can see, the Linux node pool is created right now. 3 nodes will be spin up in this panel, as you can see, 1, 2, and the third one. A couple of minutes later, I will have an access to my new target cluster. So with one command to enable, Kubernetes environment is very easy. On the next upcoming session, I will focus on the just for AKS-HCI, but today I'm focusing on the Arc. Maybe I can access it by this way. I never tried it while in creating states. Get HCI AKS-HCI cluster to list my all Kubernetes clusters in the AKS-HCI environment. So basically, I have a chance to access it. Get AKS-HCI credential -name PMR CLS. Yes to all. To retrieve this command is getting the kubectl file. So I will execute kubectl get post-A. So okay, then it just needs a couple of seconds. Calico nodes, the default CNI plugin is Calico for AKS-HCI. So I'm waiting for Calico or a CSI driver to be spinned up. Okay. Let's wait again. Our PowerShell command executed successfully. As you can see, I'm waiting my target cluster pods to be spinned up. Just only 2 pods needed to be spinned up. So I have my Kubernetes environment up and running right now. So as you can see, just a sec. As you can see, nope. AKS management cluster is the only Kubernetes environment on my environment. There's no Kubernetes environment. So what I'm going to do is I will I will project that Kubernetes environment to seem like an AKS cluster. So let's make it. To do that, just a couple of minutes ago, we prepared this command. So actually, it will create a projection metadata Kubernetes environment named PMR Arc CLS on the Arc demo group, resource group, and it will install some necessary pods on top of my Kubernetes environment in Azure Arc namespace. So let's execute this command and let's see what's going on. So this command again will create a resource name, the PMR Arc CLS. It seemed like an Azure Kubernetes services, but it's not on Azure Cloud. It is on the on-premise or on any other cloud vendor. It is not. The resources are not in Azure Cloud. All the compute resources are on my on-premise environments. So let's refresh it. I'm waiting. I will wait again a couple of seconds. Okay. Yeah, I know that. It says that the operation might take a while. I know that. So let's execute kubectl get ns to list namespaces. A couple of seconds later, I will see Azure Arc namespace in my Kubernetes environment. But first of all, it creates the projection of my Kubernetes environment. No. Try again in this view. Let's wait if we have an error or not. Try in this view again. Wait. One more time. Or let's do a full refresh. No. No namespace. Okay, let's wait. It's validating something else. No namespace. Operation take a while. I know that. I hope we can get an error. The reason is that if we can get an error, I can debug it in front of you. So again, let's execute this command. No arc namespace. Okay, cool. Let's browse somewhere else. No. So let's go to our resource group and Azure Arc demo. No resources. I know that it's going to be in a couple of minutes later. Up. Let's refresh one more time. Yes, as you can see, on my on-premise Kubernetes distribution is projected on Azure Cloud. The compute resources on my on-premise lab environment. So if you look at it, says that generic. So basically with the AZ command, I can pass the distribution and the infrastructure to here. And as you can see, it is in the status of connecting. So if I execute kubectl get ns, the Azure Arc namespace is created a couple of seconds ago. kubectl get post-n Azure-arc. So you will see the containers in here. So all the necessary containers are created, up and running, except AAD proxy. AAD proxy is important to install app services. It's important to install connect everywhere features. So we will wait a couple of minutes to enable the other extensions, but I can continue. It will be spin up, in a couple of minutes later. The slowest pod that's spinning up is kubeAD proxy. You should wait if you see that in container creating state, because it's waits some of TLS and SSL certificates to be created on that namespace. The other pods are dealing with that right now, but I can continue. So the next item will be about Azure policy for containers. So what is that? In that picture, I tried to say that for Arc-enabled policies, Arc-enabled Kubernetes, we can deploy Azure policy. And I call it actually in-cluster policies. And in-cluster policies is integrated with open source project Gatekeeper. And you publish the Azure policy from the portal, from the subscription or the tenant level. And if you enable Azure policy on top of your environment, all policies that is related to your Kubernetes environment will be applied in all Kubernetes environments. So let's assume that under your subscription or under your tenant, you have more than 50 Kubernetes cluster, and you want to centralize the policy management. So with the one single click, you apply in all your Kubernetes environment the policies that is configured by yourself. So let's go to policy, or let's not go out to policy. First of all, let's enable the extension. And let me ask you a question. So in this repository, let's say that I have a pod and it's mounting the host path. And my question is, how can you audit it? Or how can you deny that this pod to be deployed on the Kubernetes cluster? So it is for actually that's the reason for the policies. So again, let me repeat myself, but we are using the gatekeeper at the back. Gatekeeper container. Let's search for this one. Gatekeeper policy. So basically, what we are deploying on the Arc-enabled Kubernetes cluster is the gatekeeper, and the evaluation result is reported to Azure Cloud. So if I looked at my Kubernetes environment and CTI get NS, a couple of seconds later, the gatekeeper dash system will be shown in here. Show the output of the NS. Yes, 9 seconds ago. Let's look at this pods machine gatekeeper dash system. So my gatekeeper's pods are deployed, and if I execute kubectl API dash resources, grep gatekeeper. There's no grep on PowerShell. -CL. Config, constraint template, processes, blah blah. It continues like this. So to enable to actually apply my policies. So this was policy infrastructure, and this is for where you can apply your policies. And in the definitions, in the assignments, we have two important taxonomy. One is a policy, the other one is initiative. The difference between initiative and policy is just policy. A group of policies is initiative. And if I go to here and I want to deploy a couple of policies at the same time on my every Kubernetes environment under my subscription. So is the Visual Studio resource group is okay, blah blah, is continuous like that one. Initiative definition. Let's search for Kubernetes. So let's select this Kubernetes policy, and now let's click the next. So either I can deploy in the audit mode or I can apply in the deny mode. Audit and deny mode is different than each other. So in the audit mode, you can execute your uncompliant pods, but it will be reported. On the deny mode, nothing will be reported. The deployment of the uncompliant pod will be denied. So basically, we are getting leverage of a webhook in the kube-dash system. If you look at it, CTI get post-dash kube-dash system, we should see Azure policy webhook in here. So this pod determines that if it is going to be an audit or deny mode. So we will do audit mode, and these are the namespaces. You can exclude it. By the way, you can play around it, or you can include the namespaces. These are the capabilities and for enabling or dropping. So create manager identity, no. So these are the policies that I'm deploying right now. So basically, it says that no Kubernetes cluster should not allow privileged containers. So basically, I cannot deploy something like, I open two Windowses. Privilege mode. Yes, let's open this one. I cannot deploy something like a privileged container. I mean, I can deploy it, but it's going to be audited. And my cluster will be shown as an uncompliant cluster. Let's look at this one. So as you can see, I cannot deploy a privileged container. I mean, I can deploy a privileged container, but it will be audited. Privilege escalation should not allow container privilege escalation. So basically, I should set the privilege escalation to allow privilege escalation to false. Host network port range. I can set host network and port range. IPC namespace. Allowed capabilities. I can play around the capabilities. I can set the volume types. What volume types can be enabled on my Kubernetes environment. User groups and the second profiles. So I can deploy these policies on my Kubernetes environment by the Azure policy that is enabled the Azure policy extension on the Arc. So let's create this one. So if I go to the overview again, I'm going to see that what kind of policies are deployed, what are the uncompliant Kubernetes clusters. I deployed too many. Duplicate and delete assignments. I don't need it because I deployed a couple of times the same thing. Delete assignment. Yes. We evolve. That class post restricted. Do I have any other? Let's delete this one. I mean, I'm just making I added too many. I'm just cleaning up my messed environment. Kubernetes support plus. So they have the same policy. I'm deleting. It's not a fresh environment. So basically, yes, Defender extensions enabled. Defender, where are you? That one. A couple of seconds ago, I deployed this policy. And it shows me some non-started. 15 or 20 minutes range. I see that the compliance state is started. And again, let's look at it. Is custom resource definitions are deployed or not? So as you can see, the policies are deployed as custom resource definitions. So the gatekeeper extension and with the Azure policy is converting the Azure policy into a gatekeeper custom resource definition. And you can extend this you can extend these policies, by the way. So the key question is, how can you extend it? Actually, it's very easy to do that. If you go to the edit assignment, if with definition side, you will have this kind of definition as a JSON file. And the most important part of this JSON Azure policy is this temp.yml file. Just copy the policy and then let's get this policy. So basically, Azure policy is deploying this gatekeeper constraint template. So that's how we integrated it. Azure policy for definition and deployment, and gatekeeper policy, the constraint template for the compliance of the Kubernetes cluster. So the output of this evaluation is reported to Azure portal, and we are just showing that as a report from the single pane of glass. If you look at it, not started. So let's continue. We enabled the policy, and within 20 minutes later, it is going to be shown. So the second topic is connect from anywhere. It is actually, in my opinion, designed for its scenario. So if you want to connect your Kubernetes cluster, you should have an interaction connectivity between your client and then your master node, right? To execute kubectl commands to deploy your applications. But without a VPN connection or without any connectivity, I can execute kubectl commands without accessing the Kubernetes control plane. So basically, if I go back to my environment and if the client machine is here, workstation client. So in this scenario, I don't have any connectivity with the Kubernetes cluster, on-premise Kubernetes cluster. It is on-premise environment, and I'm working from the airport or something somewhere else, and I cannot connect. The only way to, the only connectivity is the internet to the Azure cloud. So let's evaluate that. Let me try to explain what I am trying to say. So cd.kube ls get config. So basically, this is the IP address of, so the server is the IP address of the, right? The IP address of the my API server, my target cluster API server. And I have the remote machine, but I don't have any access to that IP address. Let me show you. Ping. No way, I cannot access it. Destination host unreachable. Okay. So the other one is this terminal, and then I will execute curl command to API server, and you're going to see that I don't have any connectivity to the API server. Okay, cool. Ping. No, curl that endpoint. No way, I cannot access it. What I'm going to do is I will create a service account, or I can integrate the Kubernetes services with the Azure AAD, but for the making that demo environment easily, I will do a service account and a secret. So let me go to the Kubernetes services. So as you can see, my Kubernetes environment, the Arc-enabled Kubernetes environment. I click the namespaces. Okay. So it says that kubectl create service demo user. Okay. Let's create a demo user. And let's do the cluster role binding. Okay. So it says that service account token. It's just, I should do that. The second step is cd dev projects samples ls get this one. So basically, I have already my script kubectl apply -f. Not that one. Cancel. 02 secret YAML. I created the secret, and the token. Unfortunately, I'm on PowerShell. So let's execute this first of all command, and then let's play around it on the Linux because it's a Linux command. Let's copy it, and not this one. I'm trying to, get rid of the new line token. So the token is this one, and yeah, I hope it's going to work. Okay. Okay. Echo token. No way. Okay, got it. So what I'm going to do is row token is equals to no row token is equals to the secret output. Okay. Echo row token. Okay, cool. Instead of that, let's execute echo row token. I'm going to get rid of new lines and kind of stuffs. Okay, echo token. Cool. I will only copy this part. Token equals to this one. Echo again token. Cool. I have it. Just a sec. I should execute AZ login comment. AZ account list dash o table grab dash I true. Okay, so what I'm going to do is I will try to understand that on that machine I should show the subscription. I mean, I should log into my environment. So I'm checking that if I'm on the right subscription, and my AZ CLI default subscription is the Visual Studio subscription. This environment, AZ account list dash or table get dash I true. It's okay. So basically, if I AZ list AZ group list dash or table to test that actually I'm on the right subscription. Okay, everything seems okay. So what I'm going to do is I will open a proxy to my environment. Click connect, not this one. This is perfect. So let's play around this command. Cluster name is my PMR Arc CLS, and resource group is Arc. I forgot the namespace actually. So let's look at it. Azure Arc demo, and then look at it. So basically, it opens a proxy to your environment through Azure Cloud. So the Arc doesn't have the outbound connections. I mean, sorry, inbound connections. So if you look at it, the diagram, so Arc connections are always outbound. There's no inbound connection from Azure Pool to Azure Cloud to your environment. So keep in mind that all connections are outbound connections. So if I execute this command, it's going to make a proxy, open a proxy, and okay. So let me open a new terminal. So my default context is right now PMR Arc CLS. And if I execute kubectl get post-a, we are going to list the posts that I deployed on my on-premise environments. I don't have any connectivity to the on-premise environment, but with the Arc, without a VPN connection, I achieved to connect and list my Kubernetes environment, the list of the pods. So this feature is actually designed, in my opinion, is designed for edge and factory scenarios. You don't have any access. You don't want to, VPN connection. Just enable the Arc. Anywhere you can connect your Kubernetes environment. So the next topic, oh my God. Okay. Azure policy, connect from everywhere. Defender for containers. So Defender for containers is for runtime security analysis and protection, threat protection of your containers. So Defender has, in the Microsoft Defender for Cloud, there are plenty amount of defenders. Defender for SQL Server, Defender for VMs, Defender for App Services, Defender for Storage Account, Defender for Resource Group, Defender for, it continues like this. And actually, you can install 3 Defender components to your on-premises. One is Defender for servers, so server threat and protection, threat detection and protection. The second one is Defender for SQL Server, protection and threat detection of your SQL Server. And the third one is Defender for containers, threat protection and threat detection of your containers. So let's assume that scenario. Bad intended guy achieved remote code execution and downloaded malicious code inside the containers to land coin mining operations. How can you detect it? So, or this is runtime analysis, or somebody spin up and mounted the hostbed, or somebody mounted the host volume, sensitive data. So policy is for auditing, but Defender for containers is for runtime analysis. They are very different than each other. You can think like Azure policy for compliance and security posture. Defender for containers as a runtime analysis for your containers. So let's enable it. Actually, it is already enabled. The reason is that, let me show you. The reason is that if you go to Azure Defender for Cloud in the environment settings, in the edit settings, I have a rule to auto-provision Defender and policy. By this way, if any AKS is if you install Azure Kubernetes services on your subscription, or if you enable Arc on top of your Kubernetes environment, Defender and Azure policy will be installed automatically. No need to do anything. This is the, my method to enable Defender. Or you can enable Defender manually. Defender for containers and Azure Arc enable. So in this section, I should click on-premise ES Arc, and this is not, yes, this is the only command you should execute to enable Defender. And auto-provisioning is actually, if you enable this one, this Azure Defender for container components, it creates a policy to deploy Defender for containers. So if you look at these policies, Defender for, in the auto-provisioning mode, as you can see, Defender for containers provisioning Azure policy. Defender for containers provisioning Azure policy extension for Arc-enabled Kubernetes. Defender for containers provisioning Arc KRS enabled. So this policy, by this help of this Azure policy, if there's a new Arc Kubernetes environment, then Defender is installed automatically. That's a very powerful feature. And Azure policies can be installed automatically. And by the way, I finished my Azure policy, I think, not yet. Defender for containers, not yet. It is not finished. Okay, cool. So if you install the Defender, in the MDC namespace, we are going to see different pods, collector and publisher. One is collecting your security events and audit logs of your Kubernetes environment, and the publisher is publishing the events. So a couple of hours later, in the Microsoft Defender for Cloud, in the inventory section, we are going to see that the environment that I enabled for Defender, and I will have the runtime analysis of my containers. But I need to wait a couple of hours to be shown in here. And we deployed it, and we discussed about auto provisioning. And connect from everywhere. Right now we are on container insights. So normally, I mean, for the container insights, let's say that, I mean, we have the Kubernetes environment, we do the compliance auditing, we do the we achieve the install container runtime analysis. Right now we are focusing on monitoring, logging, and visualization of that environment. So the second step for any Kubernetes distribution is installing Prometheus, right? Installing Prometheus. And after install Prometheus, we have the Prometheus server. We have the Grafana, for Prometheus operator. And we have the alert manager. We have the custom resource definition Prometheus. To play around on Prometheus, we have Prometheus rule to enable rules. We have the service monitor to grab the custom, grab the Prometheus exporters. And on the other hand, for logging, this was for metrics. And for logging, at least we need to install a log database, or let's call it document type database, document oriented database. We need to have log shipping. For daemon set to ship the logs from Kubernetes environment container logs to any document oriented database. Normally we choose document oriented database. And the other one is we need the visualization tool, dashboard, another server. So basically we should understand replica, shards, and kind of stuff. We update and upgrade the log shipping product, and we will need to have the dashboards and the DAN server. So basically for metrics and logging, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's call it for the long-term data retention tunnels. It continues like that, but we should know at least 5 10 products, 8 products, 7 products. Let's assume that 7 products, and a couple of configurations, and good knowledge on sharding, replication, and kind of stuffs. So with the container insights, actually what we are doing is we are just installing very thin agent to every Kubernetes environment. Let's call it an agent, OMS agent, but it's combined with metric shipping and log shipping. I need to have fluent D. No, I couldn't find it. Let's call it this one. Okay. I need a very simple icon. Yeah, I couldn't find it. Yeah, it's okay. CDN profiles, other. I don't know. I don't know right now what to put on here. Okay. Let's put just this. OMS. Right. But actually, it's contained Fluent bits agent internally. So in the Arc, with the container inside, we have the OMS agent, and the OMS agent is actually shipping the one who ships the logs and the metrics to Azure Monitor. So let's enable it and see what's happening. So Kubernetes services and Azure Arc CLS, and then insights. Configure Azure Monitor, and let's select a log analytics workspace. I will select Azure Arc log analytics workspace, and that's it. A couple of minutes later, I will have the monitoring solution installed. I will have the log solution on my environment, and I don't have to maintain anything. No infrastructure for logging, no infrastructure for monitoring. I don't need to maintain anything. The only thing that I need to do is this extensions part. And also auto upgrade minor versions is enabled. So I'm very lucky. If there's a new version, it will be automatically deployed to my environment. Again, maintenance time, nearly zero. Maintenance cost is nearly zero. I don't need to learn the replication shards. If the data retention is needed for a long time, I don't need to install another solution on top of it. So while installing the extension, let me show what we are installing on the Kubernetes cluster. So basically on Kubernetes, kubesystem kgpo-n kube-system, we are going to see that OMS agents are installed as a daemon set. So you see that OMS agent is installed both on the master nodes, both on the worker nodes as a daemon set. So if we investigate what's actually inside it, cti get kgpo-oyaml and -n, let me hide it, kube-system, find not this one, grep image. So we have the container insights pod, and let's click inside this pod, okay? And actually see what we are using. Okay, exec-rt on decisions in dash. Okay, yes, the chef, Linux OMS agents, and td settings, Linux OMS agents, Fluent, basically, and the telegraph. So basically, we're using Fluent agent to ship the logs and the metrics to the log analytics. So let's exit. And let's continue to see the metrics and logs. So my extension installed. And this extension is installed as a daemon set on my Kubernetes environment. And when I click the insights, I will have the visualization of my environment, the utilization of my environment, and click the last 30 minutes from here. So a couple of minutes later, again, it will be populated with data. But right now, I mean, it is very small subset of data, but I have, with the container set, I have cluster utilization. I have this awesome dashboards, deployments, GPU, disk IO, disk capacity, and kind of stuff that is related to monitor my Kubernetes environment. If I click this one, it will redirect me to the dashboard that is designed from Microsoft, and thus disk usage and kind of stuff. So it is very easy to generate alerts based on these metrics. And VM's utilizations. If something is wrong, I can grab and then generate alert based on that, because it is Azure Monitor is based on log analytics. Controllers utilizations, CPU and memory. So controllers is job, cron job, daemon set, deployment, replica set, replica. What was the other name? Replication set and replication controller or something like that. I forgot it. And of course, the utilization of the containers in the 95th percentile or 90 percentile or max percentile. So as you can see, I didn't install anything. I just installed OMS agent. And if I want to generate alerts based on these metrics, I don't need to have any other alert mechanism solution on or integrate any other tool. With the recommended alerts, I can enable and then generate alerts if something happened in my Kubernetes environment. The other one is the logs. If you enable container insights, your logs will be shipped into the Azure cloud again. So container log to see last 35-minute logs. As you can see, I have everything in terms of observability, standard errors, standard output, and kind of stuffs and the monitoring stuffs. So with the container insights, actually, I'm getting rid of that kind of installation. So I will have more resources in the Kubernetes environment. And the good part is, actually, let me show you one of the documents and let me show you in one of our customers what we are working on. Sentinel Azure Data Explorer. Not this one. Yes, this is perfect. Log analytics maximum data retention time is 2 years. And if you want to retain more than 2 years, we need Azure Data Explorer. So with that, I mean, we are supporting container insights. The tables that I showed you a couple of seconds ago in here, we can ship this data to Data Explorer with Event Hub, and I can execute the anomaly detection service on top of Data Explorer or Log Analytics. It is a Sentinel architecture, but I can do the same thing on Azure Monitor as well. So basically, ship your logs, ship your metrics to the Log Analytics. If you need more than 2 years, you can ship the Data Explorer, and you can execute anomaly detection on top of Data Explorer and Sentinel to understand that what's abnormal inside the containers based on the metrics. So we have the GitOps integration as well, but I'm not mentioning about it. I'm not going to enable because I don't want to get out of resources right now. The reason is that I have too many things, but I will show you a couple of things. The GitOps integration, again, with one single command, I can enable the GitOps integration if I Flux version 2 or Flux version 1. So I create Flux version 2, configuration name, I can give a name. I can set cluster level and set a namespace, and then I can deploy whatever in my GitHub repository. So let's look at it, repositories. With the GitOps integration, with the Flux version 2, it is very easy to install Monterey, Cassandra, Galera, Java, Nginx, Prometheus, Redis, sources, and kind of stuff. If I change something on the GitHub repo, everything will be applied at the same time on the Kubernetes cluster that are enabled GitOps integration on top of Arc. I'm not going to install, but on the next session, maybe I can focus on just for GitOps integration. So let me talk about SQL Managed Instance and data services, and let me show you how it is easy to install SQL Managed Instance or PostgreSQL server on any Kubernetes cluster. So basically, custom location for the data controller and SQL Managed Instance on PostgreSQL server, the first thing that I should know is custom location. Custom location, you can think like a West Europe, North Europe, and your region. While deploying, we are converting your Kubernetes environment something like a region to install PostgreSQL server, because we need a place to install it, and you select normally in the cloud West Europe, North Europe, East US, West US, and kind of regions. And you have the Kubernetes environment. So with the custom locations, we are bringing that region feature to your Kubernetes environment. So by this way, you can select where while you're deploying. Data controller is actually for installing installing PostgreSQL server or SQL Managed Instance. It's a controller object, a plain controller object with Grafana, with logs, infrastructure, and kind of stuff. So once you have the data controller, you can ship your logs and the metrics again to Azure Cloud just based on SQL Managed Instance or PostgreSQL server. So basically, it's a plain controller object for Kubernetes to reconcile the PostgreSQL server and SQL Managed Instance. So let's deploy Arc data controller on my Kubernetes environment. So it says that Azure Arc enabled Kubernetes cluster, direct connectivity mode. Yes. And resource group is Azure Arc demo, and data controller name PMR-PC. So I just setting a name for my data controller. So I don't have a custom location for my Kubernetes environment. I haven't enabled it. So I'm saying that PMR loc and PMR location or PMR region. And the cluster is Premier Arc CLS in the Azure Arc demo. So by this way, I will select North Europe, West Europe, and Premier region. So Kubernetes configuration template to enable Arc data controller. So you can customize this dashboard, but I will choose Arc AKS-HCI because I deployed my Arc on top of Arc-HCI. Data storage class to persist data. Log storage class to persist logs. Either I can install the data controller and the SQL Managed Instance or PostgreSQL in the node port or the load balancer. So basically, I have a load balancer feature on my Kubernetes environment. That's why I'm choosing the load balancer. If you don't, data controller object will not will prevent you to install SQL Managed Instance. These are important parts. If you don't have a load balancer on your Kubernetes environment, don't select it. Node port will be your choice. Username, let's call it Pamir, and let's set a name. Password, sorry. Okay, I'm good to go. Additional settings So enable metrics uploads. Of course, I will enable it because I want to monitor and the log shipping to Azure Cloud and Azure Arc Log Analytics Workspace. What I need is, again, I should set the Log Analytics Workspace ID to ship logs. I need the password, Azure Arc LAW, and to get the keys, I need to go to agent management in here and log on to the agent instruction, primary key. Let's copy the primary key and let's put that key to ship the logs upload. Automatically, it's going to be enabled. Tags, data center. Let's call it data center. Let's call it Ireland. So city is Dublin. Status. Now I need to do that, or I can add the custom tags. And let's create data controller. First, it will be validated, and after that, it's going to be deployed. Submitting deployment. Cool. So now I need to do that because I have the proxy extension. Watch Kubernetes to see that actually my namespace is created. MDC, Kubernetes, and a couple of seconds later, my region will be seen as a namespace. That's how we are, mimicking the regions on the Kubernetes cluster. Let's wait. And let's see that if there's an error or not. Cool. PMR region will be installed as a namespace. And after that, I have a chance to show you the SQL Managed Instance or PostgreSQL Server installation. Primary region is in here. So Kubernetes, I will change my default namespace. And let's list pods. So Bootstrapper will enable data controller. Data controller will install the logs and if you want to, retain your logs on the on-premise, we have that environment. We have that feature. No need to ship your metrics or the logs to the cloud. So we are providing the feature. Either you can ship your logs metrics to the cloud via data controller, or you can retain your logs and the metrics on-premise on top of your Kubernetes cluster. So it will take roughly 5 minutes to enable the data controller. And let's go here. Primary region is extension is installed, region is installed, and data controller is in progress. Again, let's wait. Yes, data controllers. So controller object is created. Controller objects database is created. We're waiting for them right now. As you can see, installing SQL Managed Instance with disaster recovery options, backup options, monitoring, logging, high availability, and kind of stuff, it takes roughly 10 minutes. Normally, we install SQL environment in 2 days with monitoring, logging, high availability, backup options, and kind of stuff. It really takes too much time, but with that option, we are providing the cloud experience to your on-premise environment. So basically, you're managing and installing the databases on your on-premise environment through Azure Cloud. So basically, you can integrate Azure Resource Manager or your Terraform files, and then you can deploy whatever you want to your on-premise environment on top of your Kubernetes cluster once you enable the Arc. So let's wait again. Controller DB is created, waiting for metrics and logs pods to be enabled and installed. Okay, let's go to the resource group. From your DC. So as you can see, this resource is currently being created. This is important. The reason is that if it says, if you have that warning in the portal, then you cannot install SQL Managed Instance or PostgreSQL Server. This warning message should be disappeared. That's why I'm waiting for. So logs infrastructure is installed, waiting for my pods to spin up, my metrics dashboard and the metrics infrastructure is deployed. I'm waiting them to be spin up. And after that, this message will be disappeared. Or let's say that you don't have a load balancer and you installed data controller as a load balancer. So by this way, if you see something KG-SVC in pending mode in here, you should reinstall the data controller with the right configuration. So to install the databases, Postgre or SQL Managed Instance, this message should be disappeared. All your infrastructure should be up and running mode. Sorry. So everything is up and running as expected. And let's see. I will wait 10 more seconds. So this message will be disappeared because everything is up and running right now. Watch KGPO. No, it's not. Logs UI is spinning up. Let's wait. So you can enable metrics and logs on the Azure cloud, or you can enable and see the metrics and logs on your on-premise environments. Two to three. Three to three. Okay. I have my data controller. So it says that Active Directory integration. So you can enable the Azure Active Directory integration on your SQL Managed Instance or your PostgreSQL Server. Let me fully refresh it. Okay. Let's wait to disappear this message. Okay, so I have the data controller, and let me show what I have in here. KG-SVC. So it says that to reach out the logs, not in here, yeah, in this one, HTTP, and then port number to reach out the logs dashboard. It was okay. If I'm remembering my password correctly, I will reach out the my environment. So basically, this is we have the Kibana for on-premises, data controller and SQL Managed Instance and PostgreSQL Server logs, or you can ship the logs to your log analytics. Dismiss. Or let's reach out the metrics endpoint. HTTPS. I think this one. No. Yeah. Perfect. Again, my username and password. So let's look at these dashboards. So if I enable PostgreSQL Server, install PostgreSQL Server, SQL Managed metrics, I will have the metrics in here. So let's continue. Again, I go to the Arc and then PostgreSQL Server. I want to install PostgreSQL Server on top of my Kubernetes environment, right? With the help of Data Controller. I select my subscription. I select my resource group, PMR Postgre, and then custom location. As you can see, I'm choosing a custom region, like North Europe, West Europe. Service type is load balancer. And let me give my username and super complicated password, which is 123456. And CPU. You can set the memory request, memory limit, CPU request, CPU limit from here, and your data storage classes from here. So KGSC to list the storage classes. So I have the default storage class. So that's why I'm not changing the default storage class. But if you have portworx, if you have, let's say that NFS, GlossRFS, and kind of data storage classes, you have a chance to set it from here. For deployment, okay, you can select it. I will select this one, apply it. Okay, vCore, and I think it's okay. Let's apply it, and then let's create the tags. I will not create the tags, and that's it. The running validation is okay, and let's create it. Couple of seconds later, my Postgre environment will be up and running. So let's see what's been deploying. Watch KGPO. Okay, still is in progress. So as you can see, PostgreSQL Server is in progress. So right now it is installed as a single instance, but we have the Citus extension. So basically, in near future, you will have the Citus is installed on top of your Kubernetes environment, and a couple of PostgreSQL servers will be installed on with sharding and replicated scenarios. It will be installed on your Kubernetes environment. Okay, cool. I installed PostgreSQL Server, and if I want to, want from my pod, I have a chance to, from the Grafana, I can get it. If I want to get let me close this once. If I need to monitor my PostgreSQL Server, I have the dashboard. Exactly the same dashboards are available on Azure Portal. And let's see. And let's connect to the PostgreSQL Server with the help of pgadmin. And first of all, let's look at the service endpoint, kgsvc-n, PMR region. Of course, on PowerShell. No, I'll not do that. I'll look at it from my environment. KGSVC. So external service endpoint. So from PostgreSQL Server, cancel servers, register server. Let's call it PMR Postgre. Connection is this one. Main username is Pamir. Password is super complicated password. And let's save it. Crypto key is missing. Okay. Crypto key is missing. Let me search this error. It says that crypto key is missing. Okay. Interesting to see that. Let's search for pgadmin. Crypto key is missing. I'll not do that. I'll not restart. Let's look at it. Okay. Okay, let's enable master password. I think I have a problem with the PG admin stuff. Leave. Let's open PG admin one more time. Okay. Let's create register server, PMR, post connection. Host is this one. User is there. Password is my complicated password. Okay. Yes. So I can access my PostgreSQL server like I do on Infra as a Service, or like I install PostgreSQL Server on VM. So we are basically, install PostgreSQL Server via data controller, and it's so easy to install. It is so easy to maintain. It is so easy to monitor. It's so easy to ship logs and kind of stuff. The operational cost is very, very low. So we are managing the PostgreSQL Server. We are managing the SQL Managed Instance. We are managing your, let's say that your Kubernetes environment from cloud. So let's look at it. If there's any question, no, I can finish. Thank you so much. And